So we filled in the rest of the the rest of our functions. We've done this already. So these are a couple things I wanted to add. So first of all, I want to add this table on absolute value. So when we transform, these are the points you're going to want to use to transform. And these are the quadratic points. And I'm just getting those points off the graph. And did we do the x cubed? Did we fill this in? Okay. So just the points. Okay, are we ready? Did you not copy this the last time we did this? No. You. Are you done? All right. So the next one we're going to do is the square root function. So the square root function is the inverse of the quadratic. So how do we undo x squared? We take the square root. So this is f of x equals the square root of x. Okay, Jaylene. Is it Jaylene? Where are you? Is that right, Jaylene? Okay. What's the domain, Jaylene? Is all the way over here with a line, with an arrow. Is one of those? Do we have one of those? So where do I, hey, y'all, I can hear somebody's music. Very good. So we're going to do 0 to infinity. And is it Nikan? Nikan, is that right? What's the range? Bless you. It is. Crystal, what's the x-intercept? Where's Crystal? 0, 0, and what, that makes the y-intercept what? Joseph. Where's Joseph? Joseph, what's the... So extreme, I mean critical points. Do I have a relative min, relative max, absolute min, absolute max, absolute minimum? And it's at 0, 0. Rosa, I want the increasing interval. Where's Rosa? All right, Rosa, come on. It is. Is there any decreasing? And behavior. Where's Jose? Where? Oh. No, there's 2 Jose's. That Jose. Let's go, Jose. And behavior. X is infinity? Absolutely not. What does the arrow mean? Oh, yeah, it's the arrow. Yeah. What does that mean? Not X arrow. X approaches. Yes. All right. Then what's the next part? does x go to negative infinity? It doesn't, so we don't have that part. All right, the other Jose. Are there any discontinuities? Jump, removable, or an asymptote? None. So, Jose, is it even or odd? So, even means you would fold it around the y-axis. Is that true? No? Odd means it would be around the origin. Is it that one? So this is none? What? Okay. So here's the question I want to know. If the square root is the inverse of x squared, so this means this part of the parabola is missing. Where did it go? Like when it laid down, it just fell off the graph? It's just too hard to draw that part in, so we just leave it off? No. Why is it not there? Because we can't take the square root of a negative, right? So I can't have any negative x's, which means the function will never be negative. And also, we've restricted the domain and range, so we don't have any negative. So that's why it's not there. We restricted it. Okay, so if I was going to transform this, all right, so the next one is the cube root. Zach, what's the domain? And the range? Perfect. Jackie, give me the x-intercepts. And what does that make the y-intercept? Adriana, I want to know any critical points. Max, min, or point of inflection? Where? Very good. Ernesto, I want the increasing intervals. Where's Ernesto? All right, let's go. 0 to infinity? So you're just going to ignore this part of the graph? Where do you have to start when you do increasing and decreasing? On the left. So what is this doing? It's increasing. And what's it doing here? So what's the whole thing doing? So that's from negative infinity to... Is there any decreasing? No. Javier. Where's Javier? Give me the end behavior, Javier. Okay. Very good. It approaches, yes. Where's Anna? 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 Okay. Discontinuities? Is there an infinite? Is there an asymptote? Nope. Is there a jump? Is there a removable? So this is, okay, is that even? Can I fold it around the y-axis? No. Is it odd? I can go around the origin. Okay, reciprocal. Sometimes it's called rational. Do I have asymptotes with the rational? I do. Here and here. Umberto. I want the domain. And the range is the same. Carol. Where are you, Carol? Hidden all the way in the back. Carol, what is the x-intercept? None. And what's the y-intercept? Y? Why is it none? You can't touch the asymptote, right? And there's one on the x-axis and the y-axis. Can't touch. Okay, critical points. Is Maddie here? Where's Maddie? Maddie. Any? Max, min, point of inflection. None. Katya. Where are you? There you are, my friend. I want the increasing intervals. To what? Okay, everybody's whispering and trying to help you. There's none increasing, right? They're decreasing. Both of these are decreasing. So there's none, but the decreasing is negative infinity to 0, 0 to infinity. Paul, I want end behavior. What's it going to? It's going to 0. If it's infinity, that means it's going up, right? It's going to 0. And then x goes to negative infinity. F of x goes to what? 0. Ruby. Where's Ruby? Ruby, discontinuities. It's an asymptote. And which one do we put here? X or Y? X. Sebastian, even or odd? Why? Because it goes around the origin. So, if I'm graphing, these are the points I'm going to use, and the asymptotes. So exponential is next. The exponential has an asymptote. It's at y equals 0. And this is the point we're going to use. Stephen, give me the domain. And then what's the range? Yep. Very good. Okay. So, Michael, where's Michael? Michael, what is the x-intercept? None. And what's the y-intercept? Very good. Cynthia, any critical points? Max, min, point of inflection. Where? So point of inflection has to look like that. Sometimes teamwork makes the dream work. All right, none. Okay, where's 1? 1, give me the increasing interval. Very good. Is there a decreasing interval? No. That's because this is exponential growth. What? I'm going to write it in just a second. So, end behavior, Steve.
As x approaches negative infinity, f of x approaches 0.
Yep.
Yeah,
You're right. 0. Very good. Leslie. Any discontinuities? Where's Leslie? Leslie, discontinuities. None. And there's an asymptote, right? But it's not an x equal, so this is none. And lastly, Lizette. Even or odd? None. So I need the parent function. So here's how we get the parent function. So we start at this point. We go over 1 and count. How many did I go up? 2, so that's my base. So I get y equals 2 to the x. Now, this point right here is on every single exponential growth. Every single one of them. And who can tell me why? That's not the answer. Is not the answer. Why? Why would it always start there? Why? It can. It can start wherever I want it to. But it always starts here. So it has something to do with the asymptote, maybe. But what's the x value here? What's anything raised to the 0 power? 1. Anything raised to the 0 power is 1. So whether it's 2 to the 0, I still get 1. If it's 5 to the 0, I still get 1. If it's 1,000,000 to the 0 power, it's still 1. So every exponential growth goes through this point. And the same is true for the exponential decay. All right. So the last one we're going to do is the exponential decay. So this has an asymptote at y equals 0. It still has this point, and that would be our graphing point. This is exponential decay because it goes down on the right. The domain is still negative infinity to infinity. And what's the range? 0 to infinity. Do I have an x-intercept? None. The y-intercept is 0, 1. I don't have any critical points. If I start at the left and I go down, I have no increasing, but I have negative infinity to infinity for decreasing. My end behavior as x approaches infinity, f of x approaches 0. And as x approaches negative infinity, f of x approaches infinity. Do I have any discontinuity? No. Even or odd? None. So look, Here's the only difference when you write an exponential decay. If I go back and count up 2, I'm still 2 this time, but I can't write y equals 2 to the x because that's exponential growth. So we make this a fraction.